Look at this execution. Subfinder-D testfire.net. Executing a basic Subfinder command gives you an immediate list of subdomains. But it's an illusion. Watch how we tune Subfinder's commands to unlock the remaining 80% of the attack surface that default scans completely miss, and turn this output into an input for your next tool. Tim is a competent self-taught learner, like you. He types his command and gets a decent list. He sees immediate gratification as subdomains appear. However, he is hitting a wall. He is missing a massive goldmine of obscure assets, and his raw terminal output is entirely useless in a professional workflow. If you can't seamlessly pipe your reconnaissance data into your exploitation tools, you're just playing in the command line. You end up wasting hours manually formatting text files, or worse, entirely missing the target's most vulnerable infrastructure because you didn't optimize your Subfinder. We will fix this methodology step by step. Open your shell and deploy the Subfinder tool utilizing go install-v and paste the URL. Compiling from source aligns your toolkit with professional development standards. It guarantees your tool is parsing data using the most current framework. Fire the initial scan, Subfinder-D testfire.net. Review the command line interface as it updates. The rapid output provides a necessary psychological win. This default command operates by scraping the internet's memory, not the target's live servers. You have a workable dataset, but the data is incomplete by design. Running this base command gives us a decent list, but if we stop here, we are missing about 80% of the target's actual infrastructure. Tim quickly realizes the output is a roadblock. You must feed your Subfinder API keys from Shodan, GitHub, and similar platforms to unlock their full datasets and bypass anonymous throttling. Navigate your shell to the configuration path cd/.config/subfinder. The file you need is providerconfig.yaml. Obtain your free API keys from the respective provider portals. Start at the Shodan portal. Access your account settings to retrieve your primary API key. Copy it and carefully paste it into the configuration file, ensuring your YAML indentation remains flawless. Execute the same procedure to embed your GitHub token. This methodology applies to every threat intelligence source listed. Save the buffer and close your terminal editor. Save your configuration and execute the Subfinder command again. You instantly pull down a massively expanded, high-value dataset, exposing the subdomains that standard tooling leaves behind. With the API configuration complete, Tim successfully expanded his subdomain dataset. But right now, the scan is messy and data that vanishes if the terminal closes. Professionals build workflows. Amateurs read terminal screens. Raw terminal output is useless. The data disappears the moment you close your session. The output of your recon phase must become input for your exploitation phase. To capture this data, we use the output flag, running Subfinder-D testfire.net-o targets.txt. Saves the exact terminal output into a permanent text file. If you are feeding this into custom automation scripts, you can use the JSON flag by appending -j to format the data cleanly. One critical warning: running the -o command again will overwrite your existing file. If you want to add new domains without losing the old ones, you must manage your file appending carefully in the shell. Tim secures a perfectly clean, comprehensive .txt file of the target's entire attack surface, permanently saved and fully prepped to be piped directly into his next vulnerability scanner. Saving your targets is only the first step. Running the baseline command without resource parameters often results in dropped packets, CPU spikes, and a terminal cluttered with non-actionable status messages. In a professional environment, you don't just run a tool, you tune it. Default configurations are for beginners. To maintain operational speed and precision, you must control exactly how your recon engine interacts with network conditions and external APIs. We use advanced syntax to optimize the scan. Apply the -t flag to manage thread counts, optimizing CPU usage without dropping concurrent connections. Add the -all flag to override default limits and force an exhaustive scan across every available source. If specific sources are timing out, use -s to target specific APIs or -es to exclude noisy ones. Finally, append -silent. This strips out all tool banners and verbose logging, outputting only the pure domain strings.
With this, Tim executes a perfectly optimized silent command that maximizes speed and accuracy. We now have a massive, rapidly generated list of subdomains that can be used in Nmap directly.